Hello everyone, my name is Viraj and today we'll be looking at the 21st problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So I'll be moving on to my sheet over here, ticked off 900, and let's go to our 21st problem, make it divisible by 25. Alright, let's read this problem. It is given a positive integer n. In one move, one can select any single digit and remove it. That is, one selects some position in the number and removes the digit located at this position. Now this operation cannot be performed, of course, if there is only one digit that remains, and if the number contains leading zeros, they are automatically removed. Alright, so they have given you a nice example over here of what they are trying to do. Basically, what are they asking at the very end? They are saying that once we get this power of removing any digit which we want from any location, we want to find the minimum number of steps to get a number such that it is divisible by 25 and it is positive. Now it is guaranteed that for each n occurring in the input there is an answer that exists, and it is guaranteed that the number has no leading zeros. So they have given some claims also over here. We'll just see and generalize the question, what do they mean first of all, and then we'll see what's the meaning of each and every sentence. Alright, so the question starts off with a very basic thing. They are saying, I'll give you an integer n. Alright, now this integer n can, of course, is claimed that it will not have any leading zeros. That's the first point. What is the meaning of this? Leading zeros basically means that, okay, if you're talking about the zeros from the left hand side, if let's say there is some number that looks like 0, 0, 0, 1, 2, 3. So basically this number is equivalent to writing 1, 2, 3 only, because you know that these three zeros that are coming in the very left hand of the number have no symbolic meaning, because they are not contributing to make the number anything. They are basically like, even if you remove these zeros, it doesn't matter. That's why they are termed as the leading zeros, as in zeros that lead from the left hand side. And hence what are they saying is, first of all, a very important point, the input that is given, that's the number n, will have no leading zeros. Alright, great. Now what are they trying to tell you is something like this. If they say that you have a number n with you, you basically have a power. We'll call this an operation. Or right, in this operation, what are we allowed to do? We are allowed to remove any one digit in n. So let's say n is made up of some digits. Let's say the number is like 1, 2, 4, 5, 6, something like this. So I can just choose any digit for my own. I'll say, okay, maybe I'll choose 2. And I'll say I can remove this digit completely from this number. So now the number will transform to 1, 4, 5 and 6. Let's say next time I say I'll remove 5, so it becomes 1, 4, 6. Let's say I'll remove 4, it becomes 1, 6. And so on, so on, so on. Whenever I want to do it, however I want to do it, I can. I have the power to actually do this operation. Now, keep on doing this operation till you achieve what? Till we are able to get a number which is actually divisible by 25. This is the target. Now, the claim might be that, okay, I may be getting a lot of different ways by which I can make the number n come down to a number which is divisible by 25. So what's the question here? What am I trying to solve? I am trying to say that, okay, given this number n, whatever number of operations you have, tell me the minimum operations you might use to convert this number to a number which is divisible by 25. So minimum operations required to make this happen. Whatever is this value, let's say I'll call this value ops or op, simply just print this out, and that is going to be the answer. Let us look at some test cases and we'll understand this very clearly. Let's say I have something that looks like this, 5 1s 3 4 5. So sorry, 7 1 3 4 5. So 7 1 3 4 5, I'll write this down. Now in this, what we can do, operation 1, let's just say I'll remove 3. So this becomes 7 1 4 5. I'll remove 4, this becomes 7 1 5. I remove 1, this becomes 7 5. And now is 7 5 as a number 75, is it divisible by 25? Of course, if you do mod 25, you get 0, which means, yeah, 75 is of course a multiple of 25. Now, of course, you achieve the condition that it should be divisible by 25. And the claim over here is we took 3 steps to do this and we cannot do any further than this. Hence, 3 is reported as our answer. Let's discuss one more case. Let's say I have 2050047. So over here I can do something like this. You have 2050047. Let's remove this 4 and let's remove this 7. So 2 operations and you get something like 20500. And this is divisible by 2. And we took divisible by 25, and we took 2 operations to do this. Hence the claim is 2 is the answer. We cannot do any better than this. Alright, so this is like just discussing 2 cases. Of course, you can now pick up your pen and paper and understand the other cases also, and why the answer to them is what it is expected. Alright, very, very simple problem. Just remove some digits from the number and make it divisible by 25 and just find the best way of doing that, as in number of steps. What's the minimum you can go in your number of steps? Report that as an answer. Okay, so we have understood the problem, we have understood the test cases. Let's actually discuss the expected time complexity. We don't want any redundant ideas in this. How cleverly am I able to gather an intuition? That would be very much helpful if I know beforehand what sort of an complexity am I trying to look for. Alright, so I know by fact in 1 second I am allowed 10 power 8 elementary operations. And in this problem, if I go back, I have been allowed 1 second for every test. So basically one test is allowing me also 10 power 8 elementary operations. But actually inside a test, you might have a test case, right? Which is by this variable t, which is actually in 10 power 4 order. That means if I try to ask what's the number of operations you can perform for every, you can say test case, then that converts to 10 power 8 by 10 power 4. That gives you 10 power 4 again. So you basically are left with 10 power 4 elementary operations for every test case. Now, this is something that's very important, because now if you look at n over here, it's a very, very large number. It's actually in 10 power 18 order, which is somewhat the largest we can go. We would have to take a long in this case, if we understand the data types in this case. Alright, so now n being very large, if let's say, I'll take this to a new page, n being in 10 power 18 order. If let's say I want to create something like an O of n solution, is this going to work? Of course it doesn't work, right? And if this doesn't work, anything above this like n square and all doesn't work. So it's kind of telling me that, okay, classical brute solutions are not going to work. We need to even lower our time complexity in a sort of a manner where we are talking about logarithmic powers or we are talking about constant terms, right? As in, we either create a solution that looks like log base 2 of n, right? Something like this, or we create something like a constant time. This is roughly what we are trying to look for. Again, it's not compulsory that we achieve some time complexity like this, but then it's giving an intuition, right? That 10 power 18 order is very, very large. That means I'm looking for some sort of a constant preferable solution or some sort of a logarithmic solution or somewhere around operations that are in this order only, because that is what will fit in 10 power 4, in this case, n being so high. That is why I know that like this is my expected time complexity discussion, and by experience I can now understand that, okay, this problem is going to require some very fast computation, and if I'm not able to perform some very fast computation, I'll end up getting a TLE even though my logic might be right. That's why I have to think very smart, and this is where we can start off thinking where our problem should go and what should our final code look like. Alright, so this is our expected time complexity discussion, very, very important. Now let us move on to our main idea. How do we finally solve this problem? So like, again, before even looking into anything, we know that effectively we are trying to check something about the divisibility of 25, right? So what's the best way to start the problem in this case? Obviously, it's to ask ourselves, what is the divisibility test for 25, right? If I know that what is the divisibility test of 25, if I know the answer to this, maybe my problem is going to look much more easier, right? So divisibility test of 25 somewhat says, like, you can do a quick Google check also for this part, but I'll tell you, divisibility test of 25 looks something like this. We basically are only bothered about the last 2 digits of the number, and the argument is these 2 last digits should look either like 00 or they can look like a multiple of 25. So either it looks like 00 or multiple of 25. Now these 2 statements clubbed together gives somewhat like this. You get the last 2 positions as 00, or you get the last 2 positions as 25, that's a multiple, or you get them as 50, or you get them as 75. These are the only 4 possibilities that can happen to make your number divisible by 25. Now this is a very simple mathematical check. It's a divisibility test basically of 25. You can get a very good proof online for this. You can ask Google for this, not an issue. But this logic is now going to help me, because it tells me very good information that at the very end, so let's say I have n, right? I'll just draw some random digits for this. So like from the start it has some digits, so on. And then let's say I have the last digit. So this is like D1's digit, and then this is the D10's digit, right? This is very basic. Last digit is the ones place digit or the ones unit digit. And then you have the tens place digit, right? Now, why have I not drawn the other digits is because I am only concerned with the last two places. So other digits is something I'm not going to look at. Now, of course, other digits are there, but I have to somehow make sure that if these last two digits become something like 00, 25, 50 or 75, then the number is divisible. I know I'm not going to look any further. So effectively what I'm trying to say is, if let's say to make these last two digits 00, let's say the count of operations is OP1. Let's say to make these last two digits 25, the count of operations is OP2. Let's say this is OP3, and let's say the count of operations over here is OP4. Then isn't your answer any one of this? And what exactly is your answer in any one of this? Of course, the minimum. So minimum of OP1, OP2, OP3 and OP4 is actually your answer. And this is the argument. The number of operations which is least when you try to create by brute the last two digits as 00 or 25 or 50 or 75, either of these four cases is your answer, and this is our argument. Alright, now this should make sense. This is a very simple intuition that comes from our test for 25. Effectively, it makes sure that my number is finally divisible by 25, and once my target of this is complete, I know all I have to now calculate is how smartly can I get the OP1, OP2, OP3, OP4 as an answer, and if that is with me, I know I am good to go. And this is all about the problem. This is the argument. I hope this is understandable. You can pause the video, just cross verify this in your head once again, that effectively these are the four cases only that you are looking for. Alright, now after this, the problem is all about how do you implement it. That's just the clever part in this. How do we get the proper answer for OP1, OP2, OP3 and OP4? And if you're able to understand that, the problem now becomes very, very simple. It's an implementative and a brute sort of a problem. Alright, great. So now let's just discuss this. Let's just say I take the case 1 and you want to create something like a 00 at the end. Now let's keep an example. Let's say this is case 1. So you have some digits. I'll call this like something like from the very, let's say there are maybe let's say m digits in the number. So like dm, then this is like dm minus 1, dm minus 2, so on, so on, so on. So let's say like this is d3 digit, d2 digit and d1 digit. Basically from the, I have done some 1 based marking from the right hand side. I hope that should be understandable. So this is basically the number n. Now, what am I effectively looking for? I'm doing something like this, that okay, let's just try to say I'll remove a number that is, I'll remove a digit that is a power that is given to me. But when I make this case, the first place should end up with a 0. Now, of course, it can happen that it's already 0, not to be bothered with that part. But let's just say for general purposes, right now D1 was not 0. That means, what do we want to do? Now imagine that you have like let's say D3, D4, D5, so on digits also. What happens when you remove a digit? If let's say I'll remove D3 from here, it basically, you can say that all the digits from the left of D3, like this was D3, all the digits to the left of D3 kind of move one place to the right. It makes sense? If D3 is no more in existence, D4 shifts over here, D5 shifts over here, and so on, so on, so on. So every digit to the left makes one shift to the right. And now when this happens, you know that the digits in the left have indirectly come closer to the ones place. So I can say that D4 has come much closer to D1, D5 has come much closer to D1, and so on, so on, so on. Which means removing digits is making my digits on the left hand side come, like whatever digit I remove, digits on the left move closer to the ones part. That means if let's just say there is some 0 in these digits, let's say there is a 0 over here, let's say there is a 0 over here. So what do I want to do? Can I say I want to remove, like I'll mark this with red, I want to remove all the digits from, like let's say D1 is also not a 0. So if I remove everything from here to here, that is everything from the right to 0, then 0 will automatically make its way to the ones place and 0 will land up at this ones location. And that will make sense to me because now I know 0 has landed up to D1. So now I have fulfilled sort of a 50% part of what I wanted to create at the last two locations. One last location has checked off my parameter. I wanted it to be a 0 and yes, it is a 0. And let's just say to do this, I took C1 amount of operations. So I can store that, right? All I want to do is I want to find the first 0 from the left hand side and I want to say, okay, till that region, delete everything. Use your operation, use your part, delete everything. Great. Now after this, I want D2 to also have a 0. Great. From the 0, again do your operations and say, okay, let's just keep moving on and stop at another location where I would have found one more 0. And effectively all this segment, let's say this portion also, will also be something, okay, great, deleted. Maybe the count of operation to do this was C2. So I can say C1 plus C2, it gave me OP1, because this is the number of operations I actually took to make my last two positions turn 0. Like you can say last two positions turn 0. Now this is a very simple thing to observe or visualize, to be rather. If you draw this yourself on pen and copy, you will understand that, okay, yeah, this is working. If all I effectively want to do is find the very first position from the right hand side, which is a 0, and then the next position, which is also a 0. And any region that falls in between them, that 0 and the next 0 has to be deleted, because that will effectively shift those both zeros right at those locations, that is D1 and D2, or 1s and 10s place, effectively making the last two digits as 0, 0, and that makes sure that the answer or the new number n or modified number n has become the correct number, which is now divisible by 25. It fulfills the test. Now, to do this whole thing is what we are calling when we want to do the calculation for OP1. If I modify the question now, and let's say, okay, I'm not talking about case number 1, I wanted to make 2, 5. What are you trying to do now? Are you trying to do something different than what we did for 0, 0? Effectively, no. Just the check is a bit different. Right now, we made sure that from the very left of the part, we found a 0. Then also, because we required a 0, we said, okay, now also find the next best location where you have a 0. And then whatever is left, delete it. Whatever came in between, that's the number of operations. But now you want 2, 5. So effectively, from the left part, you first want a 5, and then you want a 2. So can I say that rather than looking from the left hand side for a for a 0, I'll be looking for a 5. And then next time, from that 5, next best location I would be looking for is a 2. And then whatever is between this 2 and 5 and this 5 to the very end is deleted, and that would give me OP2. Same thing can happen with 5, 0. First find a 0 from the left, and then from the right, and then from that 0 again to the very left side, find the best place where you have a 5. That regions which you cover till that location gets deleted, and you effectively would have made 5, 0 at the end. So you made 2, 5, then you would have made either in that case 5, 0, and that gives you OP3. Same thing with 75, and that gives you OP4. So this is what we want to do. That means some piece of logic which I can write can be common. It can be called for 0, 0 also. It can be called for 2, 5 also. Can be called for 5, 0 also. Can be called for 7, 5 also. And this is the piece of logic that is going to help me create my implementation, my effective implementation to make my problem work. All right. And this is the whole problem. It's a very implementative and a brute force sort of a problem, because we are trying to go to every digit and see how greedily, to be very specific, how greedily can we make the last two positions fit our condition, either a 0, 0, either a 2, 5, either a 5, 0, or either a 7, 5. If it does, let's note those operations. Whatever is the minimum out of that, effectively our answer, hence the correct solution. All right. Great. I hope you have understood the problem. Let's move on to the code part. So again, it's an implementive code. So just follow this part with me. What are we trying to do? So what I have done over here is very simple. I'm not first of all trying to input the number as an integer. This is a very sort of a hack I'm trying to do in my code. I am trying to input the number n as a string. Now, why is this helping me, or why would that help me? It's going to help me with my implementation, because strings are going to be much easier to handle with pointers and with checks, since digits in a number are much more harder to handle. You will have to do some sort of a mathematics or some sort of a mod stuff calculation. But in string, I know I can just go to that character, and that effectively tells me what is that digit at that place. So digits are much more extractable in a string. Hence, it's a hack. I can take the input of the string, the n as a string. Then I have some possible values. They are of course strings also, because I'm trying to match. I'm trying to match either a 0, 0, either a 2, 5, either a 5, 0, or a 7, 5 at the last two locations. Then I have an answer variable, which is initially int max. Since I want to minimize this, that's the number of operations. Then for every possible value in the possible values, a vector, I'm going to call my minimum operations helper function, and I'm going to minimize whatever pops out of that with the answer variable and just report that as an answer. Hence, I know I have used some sort of a, you can say, function-based code, right, where I'm using the power of functions over here. Now, what is happening in min operations? I'm passing n over here, right? That is the number and I'm talking about in string format and the possible value, right? Am I trying to create 0, 0 at the end, 2, 5, 5, 0 or 7, 5? Now what I'm trying to do, let's see. I have an operations variable, which is 0 initially. That is this current operations, which tells me, okay, this is the amount of operations it took. Now I have a checker index, which basically is what am I checking? So it is initially pointing to the last index from the possible value. So possible value dot size is the net size of that possible value. Of course, this is like effectively every time in this case, it's basically 2. So maybe I can hard code this value, but just generalizing this is the total size of the possible value in string format, which is 2 minus 1 is actually 1. So this checker value actually starts with 1, which means that I'm starting off with the very right of the index, right? Very light of the index, because I know from the left we start with 0 and the rightmost index is going to be 1. Now this is of the possible value. So effectively you have, like if you pass on 0, 0, you are initially talking about this 0, which is like at the, like this 1, 0, which is at the very right. Then you talk about 2, 5, you're talking about this 5 first. Then if you're talking about 5, 0, you're talking about this 0. Then 7, 5, you're talking about this 5. So this is the checker index, which maintains that sort of a pointer on that location. Then I have one more index I, of course, which is again running from the right hand side, since I'm trying to find best digits possible from the right. So I runs from n dot size to minus 1, like n dot size minus 1 to greater than equal to 0, I minus minus. Now what do I do? I'll say, okay, is my current digit equal to the possible values digit that is in the checker index at that location of possible value? Did those digits match? If they did, I know checker index has to be decreased by 1, because now I would move on to check the next digit that was there. So effectively, if let's say I go back over here, if let's say I was checking 7, 5 and I have checked off 5, then I'll do a minus minus to jump to 7. So next time I want to check 7. Hence checker index decreases, it goes minus 1. And this is what I do over here. And then if I feel that checker index has actually gone less than 0, that means effectively I have exhausted everything, because I know that I have covered all the 2 possible indexes only in this case, that is 0 and 1, or basically 1 first, then 0. So you know you want to break. And if this doesn't run, then you effectively just do a decrement of the checker index. And if they don't match, then you know that is possibly a digit which you want to remove, which is not of your use. So you increment your operations by 1. Now, when you come out of this for loop, what should happen? Of course, your checker index should be less than 0. If it's not less than 0, that means whatever is the number of operations, they are not correct for you. So this is again a sort of hack implementation detail. I am saying that if the checker index is still greater than equal to 0, that means you were not able to find fully 0, 0 or fully 2, 5 or fully 5, 0 or fully 7, 5 at the very 2 last locations. That means you need to return int max, because you are trying to minimize operations. So this is a hack. I can return the very large value to my answer. Hence my answer never minimizes itself. So I'll return int max as my operations. And if this doesn't fulfill the condition, then whatever was actually the number of operations, that is returned. So this integer function calls happens 4 times and I am able to get the best possible answer. All right. Now they have made sure in the question, if you go back a small line, that answer is always existing. You can see over here, for each n occurring in the input, the answer always exists. So it's never possible to get an int max as an always answer. You will definitely get some correct value, which would be the right answer. So you don't have to worry about the not possible cases. All right. Now, great. Now, what is the time complexity for this? Of course, we're running a for loop over here. So this is basically running 4 operations only, because I'm just iterating in this possible values array. And then what about this? I am running a for loop inside the call, which is going to run in the total size of, you can say, the number that is given to me in terms of what are the digits, total digits that can happen. Now, if I go back, the digits that can happen maximum in this number is 18. As in, because it's 10 power 18, effectively, like not exactly 10 power 18, you can say if it's 10 power 18 number, they have 19 digits, right? 1 and then 18 zeros. So you can say that it's somewhat around 18 to 19 times of what is going to run for this for loop. So I can just take this somewhat like 19 to be best case, not a big worry. Maybe I can even take 20 just to round things up. And this is what is going to happen in this for loop only, because otherwise all am I doing is simple, constant, you can say operations inside this. And then I'm returning the operations. So this basically happens 4 times, and inside that, every time you make a call, it makes sure that I'm maximum running 20 operations, which means roughly, if we talk about the time complexity, I'm running something like 4 into 20, which means something like an O of 80 operations, right? Now O of 80 is very, like it's very low, we wanted something like 10 power 4, we have effectively got something like 10 power 2 order, right? It's 80 is almost like, you can say 100 order, so it's 10 power 2 order. Now, is that going to work, is the question, answer to this question. Yes, of course, it's going to work. We are not getting a TLE, our logic is right, and it fetches me an accepted solution. What about the space complexity? I'm not using any extra space, right? Am I using any extra space? No, we only have the string space, right? So if we want to be very acute, to store a string also, you require space that is equivalent to the size of that string. So we basically are taking sort of like 20 space maximum, or roughly very acutely 19 or 18 space. I can just round it up to be 20. So I can say 20 is the space I'm taking to actually store the string. 4 would be some extra space for this array, but then it's fine. We are 4 comparable to this 20 is much smaller. So superseding term is O of 20, which means space is also barely O of 20. It's almost next to constant. So we know we have achieved very good space and time in this also, and this is effectively going to run and get me an accepted solution on the problem. All right, so this is a very implementative problem, again, as I repeat, and all that was in this as an intuition was, first, how do we begin with the test of 25? That is something that's basic mathematics. If we understand the test of 25, this brute checking is all implementation. You can have various methods to do this out. Maybe you can create some of your own methods, your own functions. Effectively, if your logic is right, this should get you an accepted solution. All right, so that's all in this problem. I hope you like the video. Thank you for watching.